Welcome to the first lecture of Applied Statistics, but I don't want you to think about statistics. Right now, I want you to think of yourself as an investigator and that we are going to solve a mystery this semester. That mystery we're going to focus on this semester is depression, specifically why do young people have depression. Throughout the semester, we're going to unpack the evidence to solve this crime. That evidence is data. And I want you to think of statistics as a social investigation. And we're using these tools to answer some pretty profound questions. And I can't think of a better one to look at this semester than depression. So this starts us off this semester, but again, it continues the investigation, but we're going to have to unpack multiple things because I need to train you to be an investigator before you can actually do the investigation by yourselves.
I believe that statistics is a tool for solving social mysteries. The central question for our class this semester is, why is depression increasing among young adults? We will try to answer this question using real data to understand real people. For this semester, depression will be the crime that we will be investigating, and science will be used to determine the causes of the crime. This opening slide reframes statistics not as a set of formulas, but as a way of thinking about and solving real-world social mysteries. The chapter begins by asking students to momentarily set aside anxieties about math and instead imagine themselves as detectives. Just as detectives rely on evidence rather than intuition alone, social scientists rely on data to evaluate explanations about how society works. This perspective is especially important for students in sociology, anthropology, criminology, and related fields, where the core questions are about people rather than physical objects or chemical reactions. The chapter emphasizes that curiosity is the starting point of science, and statistics is the method that turns curiosity into structured inquiry. By framing the course this way, students are encouraged to see statistics as purposeful and meaningful, rather than abstract or disconnected from real life. At the heart of this course is a single pressing social science question: why are rates of depression so high among young adults? This question serves as the unifying mystery that guides the learning of statistical concepts throughout the semester. Rather than accepting any explanation at face value, students are invited to treat each as a hypothesis that can be evaluated using data. This framing underscores a core principle of science. Explanations must be tested against evidence. Importantly, the course does not assume there is one simple cause of depression. Over the semester, students will learn to assess whether certain factors are associated with higher or lower levels of depression and how strong those associations are. Some commonly held beliefs may be supported by the data, while others may not be. This process models how scientific knowledge advances through careful evaluation rather than opinion. The chapter introduces the data set that will serve as the primary source of evidence. Throughout the course, a large survey of college students from across the United States collected over more than 15 years. With over 3,000 respondents and dozens of variables, this data set provides a rich opportunity to study patterns related to depression and social life. Unlike artificially constructed examples often found in textbooks, this data set reflects the complexity and imperfections of real-world data. Students are encouraged to think critically about how the data were collected, who is included or excluded, and how measurement choices affect interpretation. By repeatedly engaging with the same data set, students can gradually build a deeper understanding of both the data and the social processes they represent. This longitudinal and cumulative approach mirrors how actual research programs operate, making the learning experience more authentic and transferable. Chapter 0 devotes significant attention to explaining why Excel is used as the primary analytical tool in the course. Excel is compared to a hammer in a carpenter's toolkit, useful and versatile, but not the essence of the craft itself. One major reason for choosing Excel is accessibility. as every Ohio University student already has access to it at no additional cost. This removes financial and technical barriers that can distract from learning core concepts. Additionally, Excel is widely used in business, government, nonprofit organizations, and many social science careers, making it a practical skill with value beyond the classroom. Students will learn how to organize data, create summaries, produce graphs, and interpret results without being overwhelmed. Importantly, the chapter reassures students that mastering Excel does not make someone a social scientist. Rather, it is how the tool is used to answer meaningful questions that matters. The chapter outlines a consistent weekly structure that mirrors the logic of scientific research. Each week begins by asking a question connected to the larger mystery of depression. Next, students examine the evidence by learning a new statistical tool and applying it to the data. This hands-on analysis reinforces the connection between methods and questions. After analyzing the data, students interpret the findings in plain English, focusing on what the results mean rather than just what they are. In this class, quizzes and assignments are designed to promote 3 distinct levels of learning. The first level focuses on definitions of statistical principles, concepts, and tests, which students encounter while reading the chapter. This foundational knowledge ensures that students can recognize and describe key ideas. The second level emphasizes practice, requiring students to apply concepts and tests to concrete examples after completing assigned work. This stage helps bridge the gap between theory and application. The third and most important level involves interpretation, where students explain what statistical results mean in order to answer substantive social questions. This progression reflects the course's emphasis on understanding over memorization. The chapter briefly addresses practical expectations related to technology and access. Students are expected to have a reliable computing setup and consistent internet access, as well as the ability to follow online resources linked throughout the course. I also invite students to share helpful resources, reinforcing a collaborative learning environment. This emphasis on shared responsibility reflects the broader theme that learning statistics is a collective endeavor supported by tools, guidance, and peer interaction. By acknowledging these logistical elements early, the chapter ensures that students are prepared to fully engage with the investigative process. It also subtly reinforces that technology is a means to an end, supporting thoughtful analysis rather than replacing it. Chapter 0 critiques a common problem in introductory statistics textbooks: the use of data that are irrelevant to social science students. Many textbooks demonstrate techniques using abstract or non-social examples, which can obscure the importance of data collection, sampling, and measurement. The solution proposed in this book is to use a data set specifically designed for the course, focused on depression and sociological variables such as race and gender. This approach encourages students to think carefully about how data reflect real people and social processes. The second major critique addresses the idea that experiments are the only valid way to learn about causation. While experiments are powerful, the chapter explains that many important social questions cannot be studied experimentally. Social scientists often rely on surveys and observational data to study large populations over time. The chapter emphasizes that causal understanding emerges from multiple studies and methods, not a single experiment. Context, history, and interaction all shape social outcomes, making simple cause and effect explanations insufficient. By discussing examples such as social exclusion or public health research, the chapter illustrates how patterns of causation can be inferred through careful analysis of observational data. This nuanced view challenges oversimplified slogans like correlation is not causation and encourages students to think more critically about evidence. Another critique focuses on other applied statistics textbooks is that they prioritize mathematical presentation over practical understanding. While mathematics is an important component of statistics, Chapter 0 argues that it should not be the only or primary way students learn. The chapter stresses that understanding what a statistic means and when to use it is more important than memorizing formulas. This approach helps demystify statistics and makes it more accessible to students who may feel intimidated by math-heavy presentations. Ultimately, the goal is functional understanding that students can apply in real research settings. So let's consider what I expect you should be able to do by December of this year. By the end of this course, you'll be able to 1. Read statistical tables in journal articles. 2. Understand public opinion polls. 3. Interpret research findings. 4. Use Excel to analyze data. 5. Evaluate claims made in the news. And 6. Explain important questions about society using evidence. More importantly, you'll learn to think like a social scientist, to ask meaningful questions, evaluate evidence objectively, and draw conclusions based on data rather than assumptions.